Hello everyone, welcome to this channel. If you're new here, my name is Muhammad Hasan. Let's begin our 13th part of the video series. I hope you have gone through the 12th part of video series where I've talked about refraction in prism. This video is also related to prism and I'll be talking about concept like dispersion, what is the phenomena of dispersion and why it occurs. We'll be talking into that, then we'll be diving into the concept of angle of dispersion and we'll be deriving the formula for angle of dispersion. Then we'll be looking into dispersive power. Now there's a subtle difference between dispersive angle and dispersive power, and on which parameters dispersive angle and dispersive power depends is a little bit different. We'll be looking into that because sometimes that question can come into objective. After we have wrapped up all the concept related to dispersion, then we'll be looking into some of the numerical problem in order to solidify the concept. So without any further delay, let's jump into the concept and build our concept, and yeah, let's study in style. But before that, let me roll the intro. Now let's look into the concept of dispersion of light. It's an easy topic, so let's build the concept on that. Now what is dispersion? If you look into the screen, then it's written that it is the process in which there is development of different angles for different colors of light. Okay, now as we can see it here and also in the diagram, I've written it down that a white light, which is a combination of 7 different colors. So we can see 7 different colors. This is white light, which is a combination of 7 different colors. Now when 7 colors are parallel to each other, okay, like this, then they combine to produce white color. Just remember this. When rays of lights, different colors of lights are parallel to each other, then they combine to form white color. So we can see that it's traveling in parallel direction, passes through a prism, then their direction becomes different and an angle is developed between them. As you can see it in the diagram, that after refraction, different colors are producing different angles, as a result of which now the final result what we are getting here is all the 7 colors have different angles. They are not parallel to each other. Therefore, they are not mixing with each other and we are not getting white light, as a result of which we are able to see 7 different colors, that is VIVGEOR. Okay, why we are not seeing white light? Because the answer is after refraction, different color bends by different amount, as a result of which those colors are not parallel to each other. Therefore, they do not combine to produce white. Okay, we see different distinct colors. So this is the process of dispersion, easy as that. I hope the concept and definition of dispersion is clear. That's why I've written this phenomena. This phenomena is known as dispersion of light. Once the definition is clear, now let's look into the diagram to make things more clear. As you can see, we have learnt in our earlier video that deviation is inversely proportional to lambda. In my earlier video, I have discussed this. If you haven't checked that video, then please check that video, the previous video, that is part 12, where I've discussed this concept that angle of deviation is inversely proportional to lambda. As we know, greater the value of wavelength for a given light, smaller will be the deviation. We know that lambda for red is maximum, isn't it? And lambda for violet is minimum. Since lambda for red is maximum, therefore we can see that deviation will be minimum. If deviation is minimum, therefore we can see in this diagram that the deviation as delta r is shown here is minimum delta r. Isn't it? We know the concept that greater the deviation, greater will be the refractive index, isn't it? So we can say that since deviation is less for red light, so for red light, this prism will have the lower refractive index. Therefore, I have written it here. See, the deviation for red is least. Therefore, you can say the refractive index for red will be least. As you can see it here, the lambda for violet is minimum. Therefore, deviation will be maximum, and therefore you can say the refractive index for violet ray is maximum. Okay, and I have drawn it here. So this is the deviation. How we got the deviation? See, this is the actual ray, the dotted white color. Okay, this is the actual path that the light should have followed if there would have been no refraction. But after refraction, the light has bent in this direction for violet. Therefore, the deviation for violet is this one, and the deviation for red is this one. We can see it clearly from the diagram that delta V is biggest and delta R is the smallest. I hope the concept is clear. This phenomena of light rays breaking into different colors and different colors showing different angle of bending, this phenomena is known as dispersion of light. I hope this much is clear. Now let's move on to our second concept. Okay, now let's understand the concept of angle of dispersion. Once the concept of dispersion is clear, then things will be easy. Now let's understand what is angle of dispersion. Now dispersion, if you look into the English meaning of dispersion, dispersion means spreading or distribution over a given area. So we can say dispersion is distribution over an area. Okay, so as we have seen earlier in our earlier diagram, if you look into this diagram, then we can see that the light was moving in this way, okay, and then the light got distributed over this area. So this phenomena is known as dispersion. So that is distribution of light over a given area. Okay, now let's understand what is angle of dispersion. Angle of dispersion is the angle by which the distribution takes place. That is the angle of distribution. So let's see, if this is the white light, okay, the actual path of the white light should have been this one, isn't it, if there was no refraction? But due to refraction and dispersion, angle of deviation is produced different for different colors. So let's see. So for red color, this is the angle of deviation. So deviation for red, and this is the angle of deviation for violet, isn't it? Simple as that. Now once this is clear, then angle of dispersion is very easy. We can say angle of dispersion, that is the angle by which the spreading takes place, is actually delta V minus delta R, isn't it? So this angle basically is the angle of dispersion. See, this is the area of dispersion and this is the angle of dispersion. I hope this is clear. Now how to find out the formula? We know that the formula for angle of deviation, if we take into consideration thin prism, then we have found out that delta for thin prism is mu minus 1 into A, where A is the angle of the prism and mu the refractive index of the prism. This has been already derived in my earlier video. Okay, so we'll be using this formula. So del V can be written as refractive index for violet ray minus 1 multiplied by angle of prism, and delta R can be written as refractive index of red light minus 1 multiplied by angle of prism. Now we know that angle of dispersion is del V minus del R, so we'll be using this formula directly here. So if we put the value of del V here and del R here, we'll get the angle of dispersion. So we'll write it down. Angle of dispersion is equal to, I'm just putting the value of del V. So mu V minus 1 multiplied by A minus mu R minus 1 multiplied by A. So if we take A as common, then we will get mu V minus mu R, 1 will get cancelled, multiplied by A. So this is actually the angle of dispersion. I hope the concept is clear. Basically we are finding this angle, isn't it? So you need to remember this formula, mu V minus mu R multiplied by A. Okay, if you just remember the concept, even if you don't remember this formula, if you know the concept that this is the angle of dispersion, just remember this formula, del V minus del R, and then just put the value of del V and del R, the formula in terms of refractive index, and you will get this value. Okay, so this is all about the angle of dispersion. Now one thing you need to understand, that angle of dispersion depends upon the angle of prism and refractive index. So let me write it down. The first point that you need to understand, that angle of dispersion, so angle of dispersion depends upon number A, it depends upon refractive index of the prism, and number 2, it depends upon angle of prism. Okay, this A, angle of prism. Okay, so you can see that greater the angle of prism, if you look into this formula, greater will be the angle of dispersion. Similarly, if greater is the angle of refractive index for violet, then greater will be the angle of dispersion. So if greater is the refractive index of violet, we can see that the violet ray will bend more. We know greater the refractive index, greater will be the bending. If greater is the bending, then greater will be the angle. Okay, so I hope now the concept of angle of dispersion is clear. See, one thing I need to tell you, that whenever you are learning concepts, you should learn it in such a way that you can see that concept. Understand the concept as if you can see the concept. Okay, then this subject will be absolutely easy for you. Now let's move on to our next concept, that is power of dispersion. So let's understand what is power of dispersion. Now let's look into the concept of power of dispersion. It is denoted by W and is defined as the ratio of angle of dispersion. So let me write it down for you. Angle of dispersion to mean deviation. Okay, so it is defined, that is, power of dispersion is defined as the ratio of angle of dispersion to mean deviation. Now we have already learned what is angle of dispersion. Okay, the thing that we need to learn is what is mean deviation. So let's understand what is mean deviation. Now mean deviation is the average deviation. Now if you look into the spectrum of light, that is VIBGYOR, so it starts with violet and ends with red, so the mean is somewhat in the middle. Okay, so the middle color is actually yellow, that is, this spectrum, that is yellow is the middle, is obtained from the wavelength. If you look into the visible wavelength spectrum, that is the wavelength from violet to red, then the center wavelength is actually for yellow light. Okay, so we say that the mean color for VIBGYOR light is actually yellow. Okay, so the mean deviation will be taken for the color of yellow. So we can say that W is angle of dispersion, and we have already learned the formula for angle of dispersion, that is delta V minus delta R. This is the angle of dispersion or the angle of spreading divided by the mean deviation. Now mean deviation is for yellow color, so we will say deviation for yellow. Now if you write down this deviation in terms of refractive index, then we will get mu V minus mu R bracket A. Okay, this thing I have already derived, and delta Y will be mu of Y minus 1 multiplied by A. So A got cancelled. Therefore, you can say that power of dispersion omega or W is equal to mu V minus mu R divided by mu Y minus 1. Okay, so this is the formula. Now the most important thing from this formula that you need to understand here is that W doesn't depend on angle of prism. Very important. Okay, so power of dispersion doesn't depend on angle of prism. If you look into the earlier concept, that is angle of dispersion, this is the formula for that. Angle of dispersion depends upon angle of prism as well as the refractive index of the material. But when it comes to the concept of power of dispersion, then always remember that power of dispersion doesn't depend on angle of prism. It only depends on the refractive index of the medium, or you can say that it depends on the nature of the material used. Okay, so we can say omega depends only on property of material. This is very important, and they can ask you these questions in objective. Okay, so you need to be careful. So this is all about the concept of power of dispersion. I hope the concept is clear. So these are the concepts that should be kept in mind when it comes to the concept of dispersion. Okay, so you need to remember these formulas. I hope the concept is clear. This is all about the concept of dispersion. This is a small topic. Now let's look into some of the problem in order to solidify the concepts. So let's move on. Okay, now let's look into this problem. See, I won't be giving you a problem that are formula based, because if you know the formula, you can solve those questions. I'll not give you questions like find the angle of dispersion, because if you know the formula, just put the value and you'll get it. Okay, I'll give you some objective questions in order to solidify the concept. So let's see. It says that when white light moves through vacuum, then 4 options are given. All colors have same speed. Different colors have different speed. Violet has more speed than red. Red has more speed than violet. So how to solve this? Okay, let's understand. We know that white light, when we have seen that this is the prism and white light moves in this direction and hits the prism. But before hitting, it is white. After hitting, it breaks up into 7 colors. This is the concept of dispersion, isn't it? So the question is, when the light is actually white in color, does all the colors have same speed or different colors have different speed? Now don't get confused here. See, the answer will be all colors have same speed. Now why is this? The reason is that because in air, suppose this is in air all the 7 colors are moving parallelly and they're combining into a single unit, as a result of which we are getting that white color, isn't it? Therefore all the colors have same speed until and unless it goes and enters into a different medium and it undergoes refraction. Then only different colors will have different speed, as a result of which, due to this different speed, different colors produce different deviation. And once different color produces different deviation, then all the rays are not parallel to each other, as a result of which we are getting different colors of different speed. But when it is traveling in this way, that is in a parallel manner in air, then what happens? All the colors have been combined together to form a single unit, and therefore that single unit will have the same velocity. Okay, therefore in white colors all the colors have same speed. I hope the concept is clear. Okay, now let's move on to our next question. Now let's look into this figure. It says that this is a prism. Okay, a white light comes and incident on that prism, and the figure shows that the green light after refraction in the second surface undergoes grazing emergence. So which of the light will undergo total internal reflection and which of the light will not undergo total internal reflection? Now if you have gone through that concept video or the ray diagram that I have shown in this video earlier, then it's easy for you. Okay, so let's see. We know that for VIBGYOR, so this is our green light. Okay, so violet light will show greater deviation than red light. Why? Because violet has the least wavelength, that is minimum wavelength, and red has the maximum wavelength. Therefore, deviation for red will be minimum and deviation for violet will be maximum. Therefore, in this diagram, we can see that the rays that will come below green is actually blue, indigo, and violet. So we can say that for violet, indigo and blue, it will undergo total internal reflection, and for yellow, orange and red, it will undergo normal refraction. That the rays will go outside this prism for yellow, orange and red. And for green, the angle of incidence in the second surface is actually critical angle. So for this green, it is actually critical angle. I hope the concept is clear. Okay, so anything beyond critical angle will undergo total internal reflection, and we can see that violet, indigo and blue will have bending more than green. Therefore, absolutely it is having an angle greater than the critical angle. Therefore, it will undergo total internal reflection. I hope the concept is clear. So 3 questions can be asked from this. That is, which rays will undergo total internal reflection, which of the ray is having critical angle, and the third question is which of the rays will undergo refraction in the second surface. I hope the concept is clear. So this is all about the concept of dispersion, and if you just remember the formulas, then you're good to go and you can solve any questions from this part. I hope the concept is clear. So yeah, this is all for this video. If you enjoyed this video, then please give it a thumbs up. If you haven't subscribed to this channel, then please consider doing so. Till next time, enjoy your studies and build your concept, and I will catch you all in my next video. Bye bye.